Hello everybody. Hope you guys are doing well. So now we will be seeing some async module in Python. The goal is basically to understand how async is going to work in Python, right? So let's see. Uh oh yeah, this is up, right? We can, yeah, just get rid of this. Okay. Um okay, so let's see. So there are different methods in which we can achieve asynchronous programming, right? So by asynchronous programming, what we are trying to achieve is concurrent or parallel processing, right? I mean, there is no blocking. For example, when you're doing an IO intensive, right? For example, you're reading a file. So this will happen in the background, right? And then once it is ready, it will be notified to us that I am ready, and then we can uh, fill in the content, right? So basically, our goal is to avoid this blocking behavior, right? Whenever we have all languages are synchronous, right? They work. Uh, so like by synchronous, what I mean is your code will be executed in a top to down fashion, right? So for example, if this is your code block, right? And you have written lines of code, right? So the way the execution of program is going to work is basically you're going to execute or write code from in a top to bottom fashion, right? In a top to bottom. So what if at this line I want to do some async operation, right? So when we want to do async operation, our main goal is we don't want to block the thread, right? That means what we want is this operation should go out, it should be running somewhere else, and the code execution should still continue, right? So there are different ways in which you can achieve this asynchronous behavior, right? So what you can do is, so one of the way or the method to uh, achieve asynchronous behavior is we do something called so there are different methods. So like uh, so the most common methods of achieving asynchronous is uh, there are two. People broadly classify them into two types, right? What is happening? Some glitch. There are two major ways of achieving asynchronous, right? So one is basically you make do something called as multi-threading. The other way of achieving is basically making use of an event loop, right? So basically you have a event loop which is running. Now both mechanisms have their own advantages and disadvantages, right? If you have too many threads being created, um, so too many threads will result in more overhead, right? And every time you have to switch from one thread to the another, the state of the previous thread needs to be stored, right? So this is basically at you can say this is at multi-threading at OS level, Also, this is basically we are more towards the OS level. Now, this is basically this so event loop does not have that multi-threading feature, right? So basically, event loop will have less overhead as compared to multi-threading, right? So the way asyncio or the way asynchronous operation is achieved in Python is using an event loop, right? So let's study like how uh, how is async uh, behavior in Python working, right? Let's try to um, gain more information important of let's try to dive a bit deeper, right? So, okay, so for example, now in Python we have something called as uh, so we need to understand behind behind the scenes working, right? Okay, so let's see. In fact, you can refer to Python docs if I can do that. Uh, so Python kind of does something called as cooperative multitasking, right? So what is going to happen is so so the core functionality is basically the event loop, right? Let's study or let's check Python docs. Let's go to Python docs, and from there it will be more clear, I guess. So we have opened a documentation. Is it? I guess it won't be available. Yeah, no, it should be there. So this is the docs, and here you are going to search about event loop, or even you can do asynchronous programming, right? Now, so basically, this event loop is present in async IO. So let's the event loop is the core of every async IO operations. Event loop runs asynchronous tasks and callbacks, performs network IO operation, and runs a process. So what he's trying to say is the event loop is at the core. Now, application developers should typically use the high-level async functions such as async.run, then should rarely need to reference the loop or call its methods. This section is only intended for authors to of lower-level code who need finer control over. Okay, so now what Python does is you can even control the event loop, right? You can get the current loop, and so it's deprecated in 3.1.2. Deprecation is emitted. There's no current event loop. In some future releases, this will be an error. But then, okay, so previously Python used to allow us to do so how to so this is basically when called from a coroutine or a callback. Example schedule. Okay, let's have a diagram of how a function goes into a sync using event loop. Let's try to understand this. This will give us a bit more detailed explanation, I feel. Okay, So basically what is going to have is this event loop is going to track, I guess. So in JavaScript event loop you had different um, methods, right? Is it similar to the JavaScript? Yeah? I guess it's both of them are the same. It's conceptually similar, but there are differences, right? For example, uh, oh, it's one of the same thing, I guess. If that is what he's trying to say. I guess it is very. Oh, you can do TLS over it as well. This is cool. So async loop start, or you can do this. So this is basically server side. You can do that TLS section. Oh, this is cool. Okay, so the thing is, so whenever you have that asynchronous operation, right? The event loop is responsible for checking if the async operation has been completed or not. But okay, so whenever you so with uh, yeah, so this is the us. So what is good? So there are two broad categories, right? So here is basically so first is basically you have the Python virtual machine, and then you have memory, right? And then you have the event loop in asyncio library. This is specifically present in that asyncio, right? The only difference between so for example this is a piece of code, right? So okay, so for example I have a function foo, and then here I'm doing some file reading, right? So the moment it detects that this is a sync or the moment you have that sync operation being triggered, so this function will be triggered when you call the function, right? So you need to call this, suppose you're calling this, and it so there are certain functions itself, okay, which will indicate that this is an async, right? For example, it could be file reading, it could be performing a network call. So there is a list which is says, okay, so if I am able to show, let's have this as a we can we shift this thing down? Yeah, let's have it on top so that I can see both. Okay, so what is going to happen is, so basically these are the event loop methods, right? So what all things or what all could be um, causing for me to go in the async, right? So basically you have this whenever you're creating servers, you're opening connections, you're doing transferring files, you're doing a DNS lookup. So all of these are basically the methods in the event loop, right? So basically the event loop recognizes that this is a async operation, right? And whenever it gets any of these methods, it says that this is an async operation. So this goes to the event loop, right? So the event loop is responsible for tracking and monitoring for async, right? So event loop is responsible for doing the tracking and monitoring, right? So so the event loop job is basically to keep an eye out. So whenever it sees an async operation, so it could be anything. It could be like making scheduling callbacks or future task or doing some network connections. So what is going to happen is it is going to go in the wait stage and wait for the event loop to the event loop keeps on checking whether has the work been done. So once it has been done, then it goes back and then it resumes itself. The only difference is between the JavaScript event loop and Python event loop is the JavaScript event loop keeps on running continuously. Like uh, there is no like it keeps on cycling. Right? It's like a infinite cycle. It keeps on going up and down. Only thing is the event loop is triggered. Only so here the event loop does not, because in JavaScript you are looking for a specific function, right? For example, you are checking whether there is any. So it's basically if there is an async within an async. For example, first thing you made is a call to timer, and then in that timer you are checking if the file has returned or if the file transfer is done or not. So then that continuous cycle keeps on going around and around, right? But then in Python there is no continuous checking. It's like whenever it performs an await operation, it goes to the event loop, it completes the IO, the remaining whatever is synchronous operation is completed, and once the asynchronous operation is completed, it goes back to the event loop saying that okay, the work has been done, and then the remaining code executes as it is. But the okay, so so JavaScript has this promises, right? So the what promises does is uh, if you're using promises in JavaScript, you're not blocking any further code, right? But then if you are using await, what it does is anything written below await will be blocked, and it will wait until that async operation is completed, or that until that await has been completed, it will wait till there. Once that await has been done, only then will the next statements will it will execute. So this is so JavaScript has both features, right? You can do in async, that is you can continue the with the next code using promises, but then if you do async await there as well, um, async await will not will stop the execution. Remember, there is a blocking that happens whenever you use async await. So here is again in Python async using await, uh, we block below operations. Do we block them? Yeah, it basically pauses the current coroutine. The whole thread is not paused. The whole thread is not paused. The current coroutine that we are executing, that gets blocked. For example, okay, I mean, So basically, oh, so this is something. This is something nice. Oh wait, wait. Now this is again. The promises. Yeah, it keeps on changing the function. There is no, so yeah. So the only thing is, if you're in that specific function, you'll have to wait for the await to be completed. So if in a function await is written lines below it, we'll have to wait because you are awaiting for that completion, right? Yeah. So it's, yeah. So basically, it's that await thing. However, um, that is not true. Only the rest of the program or the other syntax run during at that time. So what is going to happen is, so it does, if you have a function, uh, but then yeah, you can avoid that behavior. In the only advantage I see here is, so the moment you hit that await, right? So suppose these are lines of code written, right? And then here I am going to have that await call. So anything written below await. So if this is code below, this will have to wait or await. So here is when the event loop is coming in. But in JavaScript, you have something called as promise chaining, right? So promise chaining will overcome this thing. It will run, all the asynchronous code will run waiting for the promise. But then the thing is, they become difficult. So it won't be paused. It will keep on chaining the functions. So anything below that will, however, this is still asynchronous in nature. Um, I mean, uh, inside the, when you're in the function that you're writing await, you kind of go in that asynchronous lock. Yeah. So basically, await will suspend the execution of the current async function until the promise is resolves. So if I'm waiting for a resolution, that itself is going to make the code synchronous, I feel. But then, yeah, because, so suppose if I have this function, okay, mm, I have this function, right? The moment so how it's going to work is, so this is going to call, right? This is the function call that is being made. So this is, I'm calling demo. Then I'm going to print this. Okay, now here is the await, right? So I'm going to wait. So until this promise resolves, this end won't come down. It will come 1 second later, right? Oh, so inside it's going to be yeah, inside it's going to be waiting, but then this outside will be printed first. Like this outside will come immediately, right? So so what happens is the control from here. Okay, yeah, I get what you're trying to say. This is inside, so this end will come after some time, but then anything written below this will still work, right? Because from here it is we are going to switch to event loop. So event loop will work in the background, but then and then it sees that if there is any other thing to be, so inside the function where it is written it will become synchronous. However outside, however where any lines written below this will still work. Oh, I see what's going to happen. um the yeah, the outside code will still work. It's only the inside thing that we are waiting for that resolution to happen. Isn't it doing that? Yeah, it is going to be sequentially. uh yeah, outside code will be working, but then inside there is a, after everything after wait must wait. That is going to be like an expected behavior. Oh, so the thing is, we are not talking about, when we say asynchronous, we are not talking about things written inside. uh, we are not talking about this execution. We are saying outside, how is the behavior outside of the function. Because if you write anything inside, it will be, so what happens is the moments it is going to see this await, it is going to move to event loop and continue in the background, and anything written below it will have to wait for this promise to be resolved. But then if there is anything, any statements written after the function call, it will still run. So it's basically for the outside thing. Inside there is still blocking. But this, if you have a promise written there, what if I'm doing promise chaining? Yeah, you kind of do that chaining thing, right? Yeah, promise and doesn't block even inside. It's fully non-blocking. This is also non-blocking, but then this is not fully. Uh, it doesn't block anything. It will keep on. Yeah, that is very good. Right. So promises are better than async, I feel. Promises have that uh, full non-blocking behavior. Then await. Yeah, it is more non-blocking than await. So then whenever you're doing, oh, so whenever you have that promise, you go into that micro task queue, right? And you wait. Because the event loop in JavaScript already has that promises inside the loop, right? Yeah. However, asynchronous, so it's very careful whenever you're using await, right? Make sure that anything written below await should not be executed after, like we have to wait for that await to come up or to be resolved. Only then below that things will work. Oh. And only difference is event loop in Python is not continuous running. Only difference is that it only runs when we explicitly. So whenever we tell it, right, go and do that async. So when we have to specifically put it in that async IO run. Oh, so core routine is basically something that needs to be a part of. So routines are basically functions, right? You can consider. I mean, this is more technical jargon, I feel. So a function can also be called as a routine, right? So function and routine. So this is more when it's basically a, you have to perform a designated task, right? However, since we are mm, um, okay, so uh, whenever we are saying about routine, we are talking about some side effect or some async operation happening. Side effect basically, and function can return, right? Routines never, they are not designed to return something. So it's more when you are, so eventually we are moving towards the hardware, right? So we say it's a routine or it's a coroutine. Ideally it's a function only, but then it is very subtle difference or very small difference. Mm. So these are basically how, so basically you need to tell it to put it to, oh, so in JavaScript there are certain, the event loop contains and it's all continuous running. Here you need to start it, so you need to do dot async io dot run. However, even in that you have that is a part of the async io library. Yes, in that is that it's basically coded on C, something like that. There is a GitHub repo. I'm not remembering that now, but then there is a uh, JS async io. Oh, there is a library. There's a specific, yeah, for subroutines and coroutines. Yeah, libuv. Sorry, in JS it's libuv. Yeah, it's not part of the core runtime. It's libuv. Then you go to that. Yeah, this is that async IO in JS. Even here you have something called as async IO, but there I guess you have the event loop continuously runs. Basically how everything is going to work. So basically async IO is mostly for accessing hardware, right? Yeah, you can. There's an API documentation. Basically, these are macros, right? This is, now we are at the hardware level. Yeah. So yeah, await, inside the await function it's still synchronous. Like anything written below await will not work. Uh, Fully non-blocking behavior is achieved in promises. Then you have that, because you have the microtask queue, right? So it places that logic in the queue, and anything written in will still work. That is in case of only in prompt. But that promise, Python does not have something like promises, right? So that promises is a speciality of JS, right? Whenever you have that promises, and here you need to trigger the async IO. Sorry, the event loop. You need to write async IO dot run, and you need to pass in the function itself. Yeah, you need to do that specifically in Python. And there in JS it's continuously running, so it already has in that, so it recognizes that this is a async operation. We need to do something now, so the event loop takes in. So I guess, yeah, that is all the differences between or that is basically how async operation is going to work. We'll see some more code in Python maybe, and then we'll try to understand what's happening. So basically, this is mostly in the background stuff. This is like a good understanding of how things are working behind the scenes. I guess yeah, that's all for this session. Hope you guys liked it. I'll see you guys in another one. Till that time, take care. Bye bye.